All right, good afternoon, dear students, good evening, dear students, and welcome back to yet another session of Sasya class. Today, we will be studying real numbers and polynomials. If you don't know what we are doing and what is this series all about, let me just quickly tell you. So, dear students, we have started this final countdown for this mathematics examination that is going to happen on 10th of March. We have started from way to 2 days before, and today's 2nd March, I'm going to cover real numbers and polynomials. This is going to be a very good session. I'm going to take more than 50 plus questions and it will be a really good session. On 3rd March, you can expect circles and areas related to circles. On 4th March, we will be having surface area and volumes, yet another sessions, and you can see the schedule in front of you. If you want, you can take a screenshot of this and start following because this series is going to be really helpful for your upcoming examinations. We are going to bring some important previous year questions, the most expected questions, not expected as in like the most repeated questions which CBSE follows, and it is going to be a wonderful session. Again, if you haven't explored the Sisya app, we at Sisya class are started a weekly exam schedule. So be it in your 10th grade or if you want to do for the lower grades, we have 1 week booster course, the original price for which is rupees 99. But if you're watching the live session and if you click on the link given in the description, you can get this course for just rupees 29. So I request everyone to you can enroll on this, and there's a lot of you can explore the website also, applications also. We have a team of top IIT and NIT teachers, the best teachers of India, which will be taking your classes and which will be helping you in the preparation of examinations. So without wasting any time, let's get right into this. So just if you don't know me, some of you might know me. Some of you are seeing my class for the first time. So dear students, my name is Rishabh. I'm maths master teacher here at CISA classes. I have completed my education from IIT Jodhpur, and I have been doing this for quite some time now, more than 6 years. And in my journey, I have mentored more than 50,000 plus students, and I have delivered results. And this is what about me, but all the teachers of CISA classes are from IITs or NITs, and we combinedly have years of more than 50 plus years. And we have been doing this for quite some time now, so we know what to do. So rest assured, you just be with me in this session. This is going to be a pretty good session, I believe, and we are going to cover a lot of topics. All right, let's start. So what we are going to do is first, if you have seen the title, we are going to revise 2 chapters. The chapter 1, that is real numbers, which you have been studying from, I think, class 8, the rational numbers, irrational numbers. But in class 10, this gets into something. Well, I hope everyone has studied this. And the second chapter is polynomials. So let's start with the real numbers. A quick revision. I'll just revise everything, all the concepts, and then we'll straight away do some problems which are very important. All right. So before we starting, let's quickly recall some important concepts. So first concept that comes is are rational and irrational numbers, which we already know. If you don't know, I will just quickly recall this. So numbers which can be expressed in the form of P by Q, where P and Q are obviously integers and co-primes. This is a very important thing. Where Q is not zero are rational numbers, and the numbers which cannot be represented in the form of P by Q are known as irrational numbers. Pretty basic definition. We have been studying this for quite some time now. Next, one important term is that important fundamental theorem of arithmetic. Now, I have been covered this in our Sisya classes that how does this come across, how actually we can visualize fundamental theorem of arithmetic. But just to give you a very simple recall, it states that every composite number, what is composite number? The numbers that are having more than 2 factors, that are numbers that are not prime. So every composite number, for example, 4, 6, 8, can be expressed, and when I say expressed, I mean it can be factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So for example, if I say, let's take number 9, so 9 can be represented as 3 by 3, 3 times 3, or if we take 10, then 2 times 5. But what does the factorization is unique? That means 10 is will always be represented as 2 into 5, but apart from the order. That means I can also represent 10 as 5 times 2, right? Doesn't make any difference. So this is what the fundamental theorem of arithmetic is, that every composite number can be factorized in as a product of prime. Of course, 2 and 5 are primes. This is what we have studied in grade 6. If you recall, this is what prime factorization. This is the root principle of prime factorization. I hope everyone remembers this. Next, unless we have LCM and HCF, we have been doing this for quite some time now, but in grade 10, its definition changes slightly, not much, but slightly. It states that HCF is given by product of smallest power of each common prime factor in the numbers. We'll be taking some more examples. Don't worry about this. Let's just go through the definition first. So HCF, as I stated earlier, it is product of the smallest power of each common prime factor. And what is LCM? It is a product of greatest power of each prime factor involved in the numbers. Again, I want you to note it down or take a screenshot because the entire chapter actually revolves around LCM and HCF only. If you see, I'll show you the previous year questions. You will see the most of the questions are coming from LCM and HCF part only. Of course, the fundamental theorem of arithmetic as well, but for fundamental theorem of arithmetic, the domain of the questions are very less. So we will be doing some 2-3 type of questions, and you can expect the same type of questions in your examination as well if this topic of course comes. Next, we have the fundamental theorem of mathematics I have already covered. Next, one particular type of question is that we have certain numbers. Let's say in this question, it is check whether 6 raised to power n can end with digit 0 for any natural number n. Now, what does fundamental theorem of arithmetic says? The fundamental theorem of arithmetic says that the every composite number can be represented as a product of primes. That is very basic definition. But the most important part is that factorization is unique. So here we have the number. Let's take 6 raised to power n. Now, okay, this is n. Now, tell me, if I write 6 as a product of primes, I can write this as nothing but 2 times 3. Yes, you agree with me? Of course. Now 2 times 3 is 6. That is 2 times 3 raised to power n. Now, using the rules of exponent, I can also refer this as 2 raised to the power n multiplied by 3 raised to the power of n. Yes or no? Of course, yes. Now, according to the uniqueness part, now here, if this question comes for, let's say, 2 marks, for 1 mark, if it comes, you can easily write it like this. But if it comes for 2 marks, then you have to specify the reason. So using the uniqueness part of the fundamental theorem of arithmetic, we can surely say that the only factors are 2 raised to power n and 3 raised to power n. And come on, for any number to end with digit 0, it should have at least 5 and 2 both. Yes or no? So if you say 20, you have 5 times 2 times 2 times 2. That means we have to have both 5 and 2 as the factor. So does it have a number 5? So no. And this, since the prime factorization is unique, that is what fundamental theorem of arithmetic is. It cannot add with digit 0. Everyone getting it up till now? Great. Hello everyone. Great. Amazing. So let's move forward. Next, what we have. Let's see one more question. So one more type of question that can occur, I already told you that the domain is very small in this, and we cannot get much variety in this question. So we have done this question. I'll be doing this type of question more, and if rest assured, if you are able to understand this, you'll be able to ace this in the examination as well. So what does this question say? Come on, we have explained why 7 times 11 times 13 plus 13 and another number are composite number. So let's look at the first number. What we have, 7 times 11 times 13 times 13. So dear students, if you see this expression, can I take 13 common in this and this? Of course, why not? So let's take 13 common. What I will get? If I take 13 common, I will get 7 times 11. If I take 13 common, it will remain as 1 plus 1. Yes or no? Absolutely. If I simplify this further, this can be written as 13 times 7 times 11 is what? 77. 77 times 1 is what? 77 again. Plus 1 will give us 78. Now, clearly 13 is a prime number, but 78 we can express further, right? So let's just divide it with 2. I can also write this as 13 times 2 times 39. Now, did you understand what we do? What is the definition of composite numbers? It should have more than 2 factors. That is the number itself and the 1. Here we have more than 2 factors. 39 can also be written as 3 times 13. So clearly this is a composite number. Are you following me up till now? Quickly give me a thumbs up in the chat box if you are. All right, great. Good to know. By the way, I believe everyone's preparation is going very fine. See, these are final days, and that's why we have brought this series where we'll be quickly going through all the concepts and most expected or the most what you can say, the most repeated questions. So this is going to be a really important series. So I want everyone to do this. Next, what we have 7 times, 6 times, 5 times, 4 times, 3 times, 2 plus, times 1 plus 5. Again, same thing. If you can see 5 and 5 common here, then what I will do, I will just take 5 common. What I will get, the same big thing, that is 7 times 6 times, since 5 I have taken common, that will be 1 times 4 times 3 times 2 times 1 plus 1. Why plus 1? Because 5 I have taken common. Now, since if the thing is like if it comes for 2 marks, you have to further simplify this. So this becomes 7 times 8 is 56. 4 times 3 is nothing but 12. 12 times 2 is nothing but 24 plus 1. So clearly, if you can see, it has more than 2 factors. So we can easily assume that, giving the definition that composite numbers are the numbers that are having more than 2 factors. So clearly, it is a composite number. Hi everyone, everyone has joined. Good to see this. Next, the one very important relation, and this is true for two numbers. I'll just quickly through this. That for two given numbers, we can say that the product of LCM and HCF will be equal to the product of the numbers. What do I mean? If you can see this, this means LCM of A and B times the HCF of A and B will be equals to product of A and B. Pretty straightforward, right? Okay, we have more students joining, so good to hear that. I hope everyone's preparation is doing fine. Yes. All right, great. Good to know. Good to know. Next, let's move forward. This is for two numbers, but what happens when we get three numbers? Well, you will most probably not get the questions based on three numbers. It has never been asked in like past, I think 7 or 8 years. But it's good to know that if you have three numbers, what is the relation between LCM and HCF? It is in front of you. That is LCM of the three numbers PQR is equals to the product of numbers times their HCF divided by HCF of two numbers taken at once. That means HCF of P and Q times HCF of Q and R times HCF of P and R. Again, I'm saying it one more time. You won't get this question most probably, but still it's good to know. And the second is if we have HCF. Okay, thank you. If we have HCF PQR, then we can write it as PQR times LCM of PQR divided by LCM of two numbers taken at times. That is LCM of P and Q, LCM of Q and R, and of course LCM of P and R. Give me a thumbs up if you have understood up till now. I'm pretty sure everyone has. All right, great. I'm going a bit fast. I intend to do so because I want to focus on questions more, and this is the concept that you have been knowing for vast time now. If you want my speed to be a bit slow, please write in the comment box. Otherwise, if the speed is fine, we can continue it forward. All right, great. Next. Now, what is the question? If we have find the LCM and HCF of the following numbers and verify that LCM into HCF is equals to product of the two numbers 26 and 91. So always remember, I'm just going to write it like this one more time. If we have, let's say 26, if I express 26 as product of primes, I can write this as 2 times 13. Yes, of course. And 91 again, I can write as 7 times 30. Now remember, what did we tell you? What did I tell you? For HCF, we will see the product of, look at here, I have written it here also, the product of smallest power of each common prime factor. But here is only one common prime factor, that is 13 raised to power 1 or simply 13. And if we have LCM, then it gets interesting. Here we have to take product of greatest power of all. Since the only prime factors are 2, 13 and 7, I can write this as 2 times 13 times 7, that is 91 times 2, which will give us answer as 182. So there we have it. LCM we have found, LCM we have found. And if you have to verify that, then again using the relation that HCF times LCM will be equal to product of numbers. In this case, it is equals to 26 times 91. If you multiply this, you will get the same relation. Everyone, are you following me up till now, whatever I've taught? Great, great. Good to know. All right, let's move forward now. Next, one more question I have just brought for three numbers. Again, for three numbers, you will not get you will get this type of question, of course, but you will not get to verify the relation between LCM and HCM because no one expects you to remember the huge formula in that. Again, how will I find this? Again, going through the definition of HCF of LCM. First, let me quickly write 12 as, I can write 12 as 3 times 4 or 3 times 2 squared. Yes. 15, I can write as what? 3 times 5. And similarly, I can write 21 as what? 3 multiplied by 7. Now, just as we did in the previous case, or you can see the formula in front of you. What is HCF? HCF is going to be the product of smallest power of each common prime factor. So what are common factors? I can see 3 is as common only. Can you see any other common? No. So HCF is going to be 3. And for LCM, what will I do? I have to consider the greatest power of each common prime factor. That is, I have 2 squared, highest power of 3 I have is 3 only. Then I have 5, highest power is 1. And then I have 7, highest power is again 1. Now 2 squared is what? 4. 4 times 3 is what? 12. 12 times 5 is what? 60. 60 times 7 is what? 420. So there we have it. We have found HCF and LCM. Quickly, I'll just recall whatever we have done, just in case for the students who have joined late. So first we started with what we are going to do. Again, if you are not knowing about this, this is a series which has been started from 2 days back. We have covered important chapters like coordinate geometry, circles, and arithmetic propagation. If you haven't watched the live session, make sure you watch it in the replay of the YouTube. You can find it in the Sisya's YouTube channel there itself. Next, today we are discussing real numbers and polynomials. In real numbers, we started with the just basic definition. What is fundamental theorem of arithmetic? That every composite number can be factorized as a product of primes, and that factorization is unique apart from the order which occurs. Then we have found LCM relation, HCF and LCM. The definition is in front of you. If you are joined late, you can just quickly note it down. And we have also seen the relation between HCF and LCM for two numbers, that is HCF of A and B, if A and B are two numbers, times LCM of A and B will be equals to the product of A and B. Great. Next, we learned the LCM of three numbers that you don't need to remember, but still it's a good knowledge to know. Always the more knowledge will never hurt you. Great. So we have found this question also. Can we move forward? All right. You are back. Thank you so much. Let's move forward now. Next, what we have. So listen to this question. Now, this question is a very famous question. This has been asked a number of times in like different boards and in different forms. The thing is, you have to visualize this thing, and now it will get this. I'll tell you one very important trick also. I know many of the students maybe struggling in word problems like, sir, when to use LCM, when to use HCF. Don't worry. Just listen to this question and listen to the trick, the hack that I'm trying to show you. Okay. What is the question? Just read the question with me. It is showing that there is a circular path around a sports field. Okay, we have Sonia, which is taking 18 minutes to drive one round of the field. See, if I'm just randomly, trying to read this, it will not make sense. What I have to do, I have to make a diagram. A memory diagram also will work, but better to draw it. So, what is this circular path around a sports field? So, I will try my best to draw a good circle. Okay. Not good, but decent enough, let's say. Okay, what is it? Circular path around the sport field. Sonia. So we have a girl named Sonia. Now, she takes 18 minutes to drive one round of the field. So Sonia is taking how much time? 18 minutes. Great. Next, while Ravi. So there's another guy that is named Ravi. He's taking 12 minutes for the same. So Sonia takes how much time? 18 minutes. While Ravi, on the other hand, is taking only 12 minutes. Now, the thing is, suppose they both start at the same point. Okay, this is the same point, and at the same time and go in the same direction. This is very important. They start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Now, simply saying, now if Sonia is taking 18 minutes and Ravi is taking 12 minutes, obviously Ravi is faster, right? So Ravi will be somewhere around here, then Sonia will be somewhere around here, right? So will they meet again? Of course they will meet. Why? Because the Ravi speed is faster. So at some point of time they will meet again. We have to find what time is it. Now, dear students, the thing is, okay, great. Welcome back. Now the thing is, what we have to visualize here is, see, when to use LCM here or when to use HCF. See, the thing is, if you go by the common sense, then it is like least common multiple. So we have to find the multiples, and the first multiple or the least multiple will give us the answer. But If you are not able to understand this, always remember something. See, the time that they will meet will be surely be bigger than 18 or 12 minutes, right? Whenever we are searching for a value that is bigger than the given quantities. So we are given 12, we have given 80, but we have to see the bigger quantity. We will always use the opposite. That is, we will use the LCM. Again, I will say, what did I say again? See, whenever we have two quantities given and we, for something we have visualized that the answer is going to be bigger than these two numbers, then what will I do? I will always use the LCM part. See, first of all, it is very good that if you are directly able to visualize it. But again, since whenever you see the word maximum, no, sorry, the minimum, lowest, least, you will go for HCF, or whenever you go for word maximum or highest, you will go for LCM. In this case, 12 and 18. So what I will do, I will just find the LCM of 12 and 18. That is very easy. LCM of 12 and 18. I hope everyone knows how to calculate this. Again, let me just show you. 12 is nothing but 3 times 4. That is 3 times 2 squared. Next, I have 18. This is nothing but what? 9 times 2. That is 3 square times 2. And going by the definition, I will just take 3 and 2 and their highest power. So it will be 3 squared times 2 squared. The answer will be 9 times 4, which is 36. Are you getting up till now whatever I said? Yes or no? Quickly give me a hand. Anything. Write 7, write 2, write 3, write any numbers so that I know you have understood up till now. Great. All right. So many 3s, so many 4s also. All right, great, amazing. Let's move another question. But before that, before coming to the one important part and which can come because it haven't been asked in quite some time is that proving of irrational numbers. Now, before this, we have a very important theorem that is in front of your screen. I'll just quickly read through this. If p is a prime number, if p divides a square, p divides a, where a is a positive integer. I'll just try to make you understand this. So for this, dear students, just understand this. Suppose if I have number, what does it say? If we have a square and if p divides a square, that means p will divide a as well. For an example, let's take the number 625. So if I have 625 and if a number, let's say 5 is dividing 625, then the 5 will also divide for sure a, that is square root of 625, that is 25. This is pretty straightforward. That's why I have shown you an example also. Quickly, once again, understand this with me. What does the theorem say? Let p be a prime number. If p divides a square, then for sure we can say that p divides a as well, where a is nothing but a positive integer. I'm sure everyone got it. All right, now what is the application of this theorem? See, we use this theorem in a very important thing that is called as proving irrational numbers. So there can be only two types here as well. Let's go through both the types. The first type, of course, will be to prove numbers that occur singularly, like root 2, root 3, root 5, root 7. We will just follow one simple procedure. Done. Next, we have a plus b or a minus b. For example, we have 5 minus root 3 or 5 plus root 3, and we have to prove them irrational. Now, how to prove them? See, just memorize it for once and all, and you will never forget it, and memorize it in the way I teach you. So let's take one question. Suppose we have to prove that the number root 2 is irrational. Now, how will I do that? So here I will use a very simple, a very important proof, that is going by proof by contradiction. Now, what does this say? What does proof of contradiction say? It says that we will assume a statement knowing that it is a false, but we will assume that it is true. For example, I'll just show you a very quick example. First of all, assume the statement is you can pass in the examination without studying. Okay, then we will do something and arrive at a result that will contradict our statement. So the thing is, the statement is you can pass in the examination without studying. So what you will do? You will start playing, you will start talking, you will start going out, anything, and at the end, what will happen? You will fail. Obviously, this is what happens, right? So this is nothing but proof by contradiction. That is, I will assume a statement to be true, then I will come up with certain steps, and at the end, I will contradict my assumption, and that's why our original assumption was wrong. So, for example, if we have, let's take root 2. So, what I will assume? I will assume that root 2 is rational. We have to prove that it is irrational. I will go otherwise. I will assume root 2 is rational. So I can write root 2 as a by b. Why? Of course, because any rational number can be expressed in the form of p by q or a by b. But here one important condition is that a and b are co-primes. Now, what do I mean by co-primes? That means their HCF is 1. That is, they don't have any other common factor. For example, if you have 6 by 8, then I will always reduce it into the simplest form, right? 3 by 4, 6, 2 times 3 is 6, 2 times 4 is 8. So always A by B, where A and B are co-primes. Next, see, standard procedure, you have to remember it like this only. What I will do, I will take B here. What I will get? I will get root 2 times B equals to A. Following me up till now? Yes, great. Next, what I will do, I will square both the sides. I will get 2b square is equals to a square. Great. Now, see, if it is form of 2 times b square is equals to a, that means for sure I can say that 2 divides a square. Yes or no? Now, from 2b square equals to a square, I have that 2 divides a square. Now, going by our original theorem, if 2 divides a square, then for sure 2 will divide a as well. This is our statement number 1. Yes, yes or no, till now. So from this we have observed one thing, that if 2 divides a square, then 2 will divide a as well. Now, if 2 divides a, can I say a is equals to 2c for some another constant, another integer c? Yes or no? Okay, great. Now I will take this equation and I will substitute here. So what I will get? I will get 2b squared equals to a square, that is 2c whole square, that is 4c square. Next, I will again cut. I will get b square equals to 2c square. Great. I'll repeat what I did one more time. I have written root 2 as a by b, where a and b are co-primes. Next, I took b to the other side. I got root 2b equals to a. Then I squared both the sides. I got 2b squared equals to a square. Now, from this statement, that is 2b squared is equals to a square, I am for sure can say that 2 divides a square. Now, according to the theorem that we have studied previously, if 2 divides a square, for sure 2 will divide a, right or not? Now, if 2 divides a, I can write a is equals to 2cc. I know it is a bit complicated, but the thing is, like, you have to remember this, and the best thing is write this proof 2-3 times before the examination. Since the examination is coming, you go by heart by it. If this question comes, it will for sure come for 3 marks, and the 3 marks is in your bag. Nothing to worry. Now, moving forward, I just wrote a equals to 2c, so 2b square becomes 4c square, that is b square becomes 2c square. From this, again, what can I say? That 2 divides b squared. And again, going by theorem, if 2 divides b squared, then 2 will divide b as well. So here we have the second statement. Now, from both the statement 1 and 2, one thing is clear, that 2 divides a and 2 divides b. But what was our assumption earlier? It was that a and b are co-prime. So clearly it negates the statement, it contradicts our statement. So we can say that our assumption was wrong, and hence root 2 is irrational. Are you following me up till now? Yes or no? All right, great. Let's move forward. Now, if we have to prove another type of number, that is 7 plus root 2. Now, here it gets interesting. See, nowadays, what CBSE is asking, that it is already giving that root 2 is irrational. Now, suppose if it already given root 2 is irrational, then our jobs becomes very easier. I'll show you how. So, again, the step remains same. I will write 7 plus root 2. I will assume this to be rational. So, 7 plus root 2 can be expressed in the form of what? A by B. Yes or no? Of course. Now I will just take 7 to the other side. I will get what? Root 2 equals to a minus 7b over b. Now see, the condition is a and b are integers. So if a is integer, b is integer, 7b is also be integer, right? Again, I'm saying if b is an integer, 7b will be also be integer. A already is integer. So I subtract integer minus integer. For sure, this will be an integer, yes or no? And similarly, b will also be an integer. It is our initial assumption. Now, integer by integer will be a rational. And root 2 is, we have already proven earlier. See, this is where it gets interesting. Suppose if in the question it is already given that root 2 is irrational, we will be seeing questions. In most of the cases now, CBSE is being already giving root 2 is irrational. But in the case, if it is not given, then you have to do the previous question one more time. You have to prove that LHS is irrational while RHS is rational. And how can it be? That's why this number is irrational. Probably the most, what do you say, the clumsiest proof, but you have, once you, it is very easy. It is like a poetry in motion. You can say that. So of course you don't have to do nothing in that. Just remember the things. What I used to do and what I advise my students is just write this proof every morning. So you have what, around 9 days to go. So every morning just write this proof, because this proof is very easy, and of course this will come for 3 marks if asked in the examinations. Great. Give me a thumbs up, dear students. All right, great. So this is done. Now let's move to some important previous year questions. It took more time than anticipated. I expected it to be concluded in 20 minutes, but it took around half an hour. So no, not two issues. Now let's look at some important previous year questions on real numbers. So for the first question is LCM of 850 and 500 is what? This came in 2024. Now, dear students, I will try to solve this very easily. So 850. Now, dear students, see, this thing comes with practice. 850 and 500. Okay, now see, 850 I can write as 17 times 5 is what? 85. So I can write this as 17 times 50. Yes or no? Now 50 I can also write as what? 25 times 2. So I can write this as 17 times 5 square times 2. This thing will come with practice only, that I have seen the number 850. I quickly easily know that 850 has a factor as 17. So good. Now I have 500. So I will write this as 5 times 100, or I will write as 5 times 100 is what? 25 times 4. That is 5 squared times 2 squared. See, how am I doing this? I will not do prime factorization because this is an MCQ. Okay, no Sunday, no fun day. Dear students, no Sunday, no fun day. The thing is, we have to focus on our examinations, no? See, I'm also teaching on Sunday, right? Why? Because I care for you. This is nothing but 5 cube times 2 squared. Yes. Now recall the definition what we have. We have to take highest power, that is 17 times 5 cube times 2 square. So our answer will become very easy. That is 17 times 5 cube is what? 25 times 5, 125. 125 times 4 will give us 17 times 500. See, one marker, but still it takes a lot of time. But if you go with the procedure that I just taught you, you can do it easily. All right. Are you getting up till now, right? I know it is a Sunday, but it is important to study as well. All right, great. Let's move forward. Next, we have proof that 6 minus 4 root 5 is an irrational number, given that root 5 is an irrational number. Now, I have already taught you how to do that. I'll just tell you one more time what to do. I will just write 6 minus 4 root 5 as a by b. Then I will separate the roots in one side and the rational part on the side. So I will get 6b, this is sorry, 6b minus a over b over 4b actually equals to root 5. Now already given, I told you, see, it is already given that root 5 is irrational. This is irrational, but the entire part here will be a rational number. So can the rational and irrational be equal? No. So this will come for 2 marks, and 2 marks is in your bag. I hope it is clear. Great. Let's move forward. Now show that 11 times 19 times 23 plus 3 times 11 is not a prime number. Again, I told you we will just follow the similar procedure that we have been doing up till now. I will just take 11 common. I will get what? 19 times 23 plus 3 times 1. Now 19 times 23 you can do 3 times 1. Now what do we have? We have more than two factors. Clearly composite. Easy, right? Great. Next, oh my God, let's look at this question. What does this question say? In a teacher's workshop, the number of teachers teaching French, Hindi, and English. Now, what is it? There's a teacher's workshop, and with the number of teachers that are teaching French, Hindi, and English are 48, 80, and 144 respectively. Find the minimum number of C. What did I tell you? Not to worry whether to find HF LCM. Minimum means what? We have to do HCF. It just is the opposite of what we're doing. Minimum means highest common factor. Remember it like this. It is ulta pulta. If it is asked minimum, we have to find HCF. If it is asked maximum, we have to find LCM. Always remember ulta pulta. Great. So what we have to do, we have to just find HCF of 48, 80, and 144. Now, as you know, I'm not going to do this. If you are able to do this, if you have any problem, you can let me know. Just give it a try. You know how to find the SF. You've been so many questions now. Let's move forward without wasting any time. Okay, one very conceptual question. The total number of a factors of a prime numbers is what? Come on, what is your answer? What do I say? Okay, total numbers of factors of a prime numbers are what? See, if it is a prime number, let's say example 2. What are total factors? 2 and 1. How many total factors? 2. Answer is going to be. But dear students, let me just show you. Okay, this you have understood how there are two factors. But suppose, now here's a very trick question which you will understand. The question was the total number of factors of a prime number is, the answer is 2, the number itself and 1. But suppose if the question is the total number of prime factors, then what will I do? What will be my answer? Will it remain 2 or will it be something else? See, I'll just explain. Suppose if we take number 7, it is a prime number, right? What are its factors? 7 and 1. Our answer is correct, the 2 only. But suppose we have to find the total number of prime factors. Is 1 prime? No, don't make this mistake. There's only one prime factor of a prime number, that is the number itself. Clear? Yes or no? All right, great, amazing. Now, what we have, the ratio of HCF to LCM of the least composite number. Now, what is the least composite number, dear students? Let's see, 1 is it a composite? No. 2 composite? No. 3 composite? No. What is the least composite? 4. And what is the least prime number? Is 1 a prime? No. The least prime is 2. So, if you have to find HCF of 2 and 4, it is 2. And if you have to find LCM of 2 and 4, it is 4. So, answer is 1 by 2 or option number A. A. Why it is not working? A. Okay. Is it clear up till now? Yes or no? Great, amazing. Let's go move forward. Now we have another question that was asked in actually 2021. It is given that HCF of 13 and 91. See, if it is in brackets, don't get confused. These are the numbers itself. Sometime back, one student was like he was not able to do this question, and I asked why. He said that there was no number given. See, don't do these mistakes. The numbers are 39 and 91. HCF is given. We have to find LCM. What is the relation? 39 times, this is looking like 33. 39, oh my God. 39 times 91 will be equals to 13 times, we have to find HCF, right? So LCM, no, so we'll just write it LCM. Now quick math, 13 times 3 is 39. 91 times 3 will give us 273, or my dear students, option number B. Clear? Will we make this mistake ever again? Hello, dear students. Thank you so much for joining. Will we make this mistake ever again? If you do, then what can I do? All right, great. I know you will not. Next. Okay, one more question that came in 2021. If n is any natural number, that 12 raised to power n, this is n, my dear students. This is actually n. cannot and end with digit what? Now, simple answer is 0. I will not explain this. Okay, I will explain this. Now, 12 is what? 3 times 4 or 3 times 2 squared? Yes or no? Great. Raised to power n. Now, 3 into 2 square raised to power n, this will give us 3 raised to power n on times 2 raised to power 2n. Do you see any number 5? Of course not. That means the answer is 0. I've explained this quite in a detail in the in our previous part. I hope everyone understood this. If you have any doubts, you can let me know. Great. All right. Let's move forward now. Okay, one more question. 2019. The LCM of two numbers is 9 times their HCF. What does it say? LCM of two numbers is 9 times their HCF. And this has nothing to do with LCM HCF. This is just a way to trick you. This is simple algebra question. If you give this to a grade 7th child, he will also do this. LCM is 9 times, I will put 9 times 1 times 10 HCF is 500. HCF will be what? Come on, don't make me write. I hate writing. HCF will become as 500 by 10, that is 50. Great, pretty straightforward. I hope everyone got this. Yes or no? Great, great, great. Many students join. Good to know. Okay, now this is a very important question. See, up till now, whatever we're doing is very just pretty straightforward question. This particular type of questions are really important. Again, I tell you, find the just read this question one word with me. Find the least number which, when divided by 12, 16, and 24, leaves a remainder 7 in each case. Again, read this question one more time. We have find the least number which, when divided by 12, 16, and 24, leaves a remainder of 7 in each case. Now, how will I do that? See, dear students, again, I told you, whenever we have to find least means what? We have to go for maximum. That is, we have to find what? H, C, F. Yes or no? Next, we have for whatever we do, we have to get the answer. So, what we will do, first of all, I will write 12 as what? 3 times 4 or 2 squared times 3. Next, I have 16. I will write as 2 times 4. Whenever in this case, we have to find LCM. Apologies. And if we have 24, what I will do, I can write this as 2 times 2 cubed times 3. Next, what I will just write 2. What is the highest power? 4. And 3 have nothing but 3. So 2 times 4 is what? 16 times 3. We will get 48. But here it will be interesting. We have to find the least number which when divided by 12, 16, and 24. See, we have to find the number. That's what I told you. It's not always like this. See, the numbers have to be bigger than 12, 16, and 24, right? So we have to find LCM. We have found LCM, but what is the remainder? It is leaving 7. So I will just add 7 to the answer. I will get answer as 48 plus 7, which will give me 55. Great. Just type 5 in the chat box if you have understood this. Great. So many. Nice. Now, if HCF of 65 and 117 is expressible in the form of 65 and minus 117, then what is the value? See, this is how, to the extent the paper setters go to confuse you. Now, what, see, HCF, if you see this question for the first time in your examination, you will be probably go, what is this? I have not and never studied this. Is probably out of syllabus. But the thing is, this is not. I'll just tell you why. See, we have 65 and 117. Let's do one thing. Let's just find HCF first. So I have 65. 65 I can write as 13 times 5. Yes. And similarly, I can write 117 as 13 times 9. So if I ask you what is the HCF of both of them, clearly HCF is going to be 13, right? Now, it is expressible in the form of 69, 65 and minus 117. So what will I do? I will just equate this 65 and minus 117 equals to 13. Now 117 I will take to the R, which is 117 plus 13 will give us what? 65n will be equals to 130, and 65 times 1 60 times 65 times is 130, so n will give us 2. See, very easy question, but if you see this question for the first time in your examination, I know it can be get confusing. All right, getting up till now? Yes or no? Okay, great. Let's move forward. Now, one more question. An army contingent of 678 soldiers. I'm not going to solve this. First of all, this question came in 2017, and see what we have to do. An army contingent of 678 soldiers is to march behind an army band of 36 members in a Republic Day parade. Now, it is saying the two groups are to march in the same number of columns. What is the maximum number of columns they can march? Just seeing this thing, it is the question is saying that find HCF, find HCF, find HCF, find HCF. So what we'll do, we'll just find HCF. So can you find, okay, where's pen? Can you find HCF of 6, 7, 8 and 36? Yes, very easy to find. So whatever your answer will be your answer. I'm not going to do this. I'm pretty sure you know how to find HCF and LCM now. Let's move forward. Next, one more type of question. What is the question? On a morning walk, three persons steps off together and they measure 40 centimeters, 42 centimeters, and 45 centimeters. What is the minimum? See, that's what I will telling you. Minimum means what we have to do. Find LCM. Distance each should work so that each can cover same distance in complete steps. Do you like, are you able to visualize what is the question saying? When I'm reading this question, what I say on a morning walk, okay, I'm wake up at morning at 5 a.m. Three persons, me and my two other friends, steps up together and their steps measure 40, 42, and 45. Probably 45 is mine, bigger size, no issues. What is the minimum distance each should walk? That means I obviously the sizes, like let's say this is one shoe size, one size is like this, one size is like this. So what is the minimum distance each should walk so that they can cover same distance in complete steps? The question is telling you find LCM, find LCM. Just you have to hear it. So I have to find LCM of 40, 42, and 45. Okay, I will do this one for you. Otherwise, you will say all questions you're giving us is homework. So this is nothing but 2 cube times 5. Yes. 42 is what? 7 times 6? Or I can write 2 times 3 times 7. Yes or no? 45 is what? 5 times 9. That is 2. 5 times 3 squared. Next what? We have to just find the common numbers, write the highest power. So answer we will getting is somewhat 2520. Did you get it? Yes or no? Great, great. Good to know. Next, again, what we have shopkeeper. Again, for see, I'm covering so many word problems just for you, and we are seeing how to find. Just the thing is, once you have visualized or once you are able to find whether we have to find HCF or LCM, everything becomes easy. So, what does this question say? It is a sweet shopkeeper. Okay, great. Don't get your horses too much. A sweet shopkeeper prepares 396 gulab jamuns and 342 rasgullas. Okay, so he's preparing some gulab jamuns and rasgullas, and of course, I'm hungry. So he packs them into two containers. Now, each container consists of either gulab jamun or rasgullas. But the thing is, you either fill gulab jamun or rasgullas. But the thing is that they should have equal number of pieces, and the number of pieces he should put in each box. So the number of boxes are least. When I hear the word least, I know I have to do HCF. I will just find HCF of what? These two numbers 396 and 342. If you do this, I can write 396 as 2 times 3 times 3 times 19, and similarly I can write 342 as 2 squared times 3 squared times 19. If you find the LCM, it will come across as 80. Is this clear? This is 11, sorry. Great. All right. Up till now, clear? Yes or no? Great. Now, one more type of question, probably the we are just coming to end of this chapter. So what is it? We have to find the largest possible positive integer. We have to find the largest possible positive integer that divides 125, 162, and 259, leaving the remainder 5, 6, and 7 respectively. So this type of questions, dear students, how will I do? I will, in the previous question, what we saw, we just found the LCM and then we added. In this type of questions, we will first subtract. So since this is a remainder, I will subtract 125 minus 5, 120. 162 minus 6, I will get 156. And 259 minus 7, I will get 252. Now let's just find LCM. That's it. So I'm using the column method, that is 120, 156, and 252. Great. I will divide with 2. I will get what? I will get 18. Here I will get what? 78. And here I will get what? 126. I will again divide with 2. I can keep on doing this, going very slow this time. I will get 14. I will get 39. And I will get what? 63. Next what? I will keep on doing this. I will divide it with 3 because here I'm getting 13 and here I'm getting 21. So what is the answer? 2 times 2 is what? 4. 4 times 3 is what? 12. I hope it is clear. Yes or no? Great. Next, I have listed some questions that prove that root 3 is an irrational number. Root 5, root 2, I have shown you the years that have come. I'm pretty sure you have understood the procedure to do that. These are some questions and I have mentioned the years it has come. All right, great. So this brings to the end of this chapter. Before we start polynomials, I just want to ask everyone if you have any doubts, you can let me know in the chat box before we start the second chapter, that is polynomials. So it has been around an hour or so. We have studied what real numbers, and if you want me to quickly recall this, I'll just do it for you. So first of all, we started with what are real numbers with the definition of rational and irrational. What are rational numbers? P by Q, PQ integers, Q not zero. If they are not rational, that is, if they cannot be expressed in the form of P by Q, then it becomes irrational numbers. Done? That's it. Okay. Next, we move forward to what we started fundamental theorem of arithmetic. It says that every composite number can be expressed in the product of primes, but this prime factorization is unique apart from the order it occurs. Using this fundamental theorem of arithmetic, we are able to prove that root 3 is irrational, root 2 is irrational, and so on, so on, so on, so on. Next, we studied LCM HCF. What is HCF? We have to take the common prime factors only and their lowest powers. But when you have to find LCM, you have to take all the factors and their highest powers. We also studied HCF and LCM relation of two numbers, that is given by HCF times LCM is equal to the product of the two numbers. For three numbers, we have different formula. No need to memorize it, but again, I'm saying it's good to know. So if you are able to memorize it, it will be a very good thing. Next, we did some previous questions. So this number, real numbers done and dusted. I'm pretty sure that this will surely come for 3 to 4 marks, and I have very good feeling that whatever we have covered up till now will be asked from there itself. All right. Give me one in the chat box if we move forward. Give me two instead. This is the second chapter. We are going to study polynomials. Great. I'm so sorry. Okay. Now in polynomials. So actually, I will take this opportunity to give you a reflection of how the classes are taught in sisyaclass class. Now, be where anywhere you study, be you study in your school, in coaching classes, or in some other YouTube app. I'll just take this chance to truly reflect how we approach towards chapter. I'm not going to waste much of your time. Just 2 minutes. Just go through and be with me. So, meet this French philosopher and mathematician. His name is René Descartes. Now, what does he do? See, whenever we have this thing, I'm pretty sure you must also be doing this, that we have this thing that whenever we, let's say we encounter a question, what we will do, we'll keep on thinking about it. Also used to happen, and I'm sure many of you will be doing this. We just used to lay down on the couch and just keep about the question, what is the answer, what is the answer. So he's also a French philosopher and mathematician. Like what? Like this. He was just, casually laying on the couch, seeing the fan and seeing a fly, a mosquito or a fly, and he's going like zoom, 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 zoom towards the fin. So now what will normally you and me will think that what is this fly doing and probably get irritated. But what he understood is that he thought, can I locate the position of this fly on my roof? See, he's a philosopher as well as a mathematician, so you can expect him to think things like this. So what he did, he imagined the two fans as, so this is him imagining. So he imagined these two fans as x and y axis, and he came across some formula or some concept whether he can locate the position of the fly. And that's how the coordinate geometry was born, dear friends. This is actually a real story. This is not a made up story. And you can thank the fly for it. You can thank the scientist for it. And you know there are only two things. One is apple, gravity, and we have fly also in maths. So what we have, if you can see, we have various curves which we can plot on the curve. This is one curve, this is one curve, this is another curve, and these are some equations. But how many of these are polynomials? How will I identify them? So dear students, for this, a general form of polynomial I have given, that is p of x will be given as a n xn plus a n minus 1 x raised to 1 n minus 1 plus a n minus 2 x raised to 1 n minus 2 plus so on so on so on plus a naught. Now conditions are very 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 important. First of all, we have the condition that the exponent of any variable should be a non-negative integer. What do I mean by non-negative? That means starting from 0, 1, 2, 3, 4, and so on. Second, the exponent should not be in the denominator. This is just the result of the first condition, that the exponent should not be in the denominator. And third condition, the most important, is the coefficients should be real number. So again, quickly going through real numbers, one scientist laying down saw fly. Unlike you and me, unlike getting irritated, he saw, can I locate the position? He did this, and we have polynomials in front of us. What is the general form of polynomial? It is in front of you. Not important to know, but good to know the conditions. That is, exponent should be not good. It is very important to know the condition. The exponent should be non-negative integer, done. The exponent should not be in the denominator, done. And the coefficient should be a real number. Three conditions, done. Write three in the chat box. Great. Let's move forward. Now, one important thing is, what is degree of a polynomial? Now, what is this saying? If p of x is a polynomial in x, the highest power of x in p of x is called the degree of polynomial. So suppose if we have x cubed plus 3x squared plus 4x plus 1, what is the degree? 3. I am pretty sure this is very basic. I'm not going to waste time on this. Next, types of polynomial. Basis on the degree, I'm so sorry. Basis on the degree of the polynomials, polynomials are classified into a linear polynomial. That means if degree is 1, linear. If degree is 2, it is quadratic polynomial. And if degree is 3, we have cubic polynomial. For our, in grade 10, we will only be dealing with polynomials that in up till degree 3. I'll just tell you, if degree is 4, it is called as quartic or biquadratic polynomial. Want it to worry. Next, we have zeros of polynomial. Now, graphically, the zeros of polynomials are the x coordinates for the point where the graph, okay, graphically, the zeros of the polynomials are the x coordinate of the points where the graph of the polynomial intersects the x-axis. We'll be dealing with so many problems, don't worry about it. Next, if we have a quadratic polynomial y is equals to ax squared plus bx plus c, and it has two roots, let's say alpha and beta. Probably this is the most important part of the chapter. If we have two roots, alpha and beta, then we can say the sum of roots, that is alpha plus beta, is given by minus b by a, and alpha beta, that is product of roots, is given by c by a. Again, once again, let me tell you, if we have a quadratic polynomial of the form y equals to ax squared plus bx plus c, the sum of roots is minus b by a, product of roots is c by a. And let me just take a chance to explain you one more thing, and make sure you write it down, that if we are given sum and product of roots, then our quadratic formula equation can be formed like using x square minus sum of roots, that is alpha plus beta, times x plus the product of roots, that is alpha, beta. We will be dealing with this type of questions, so many of these questions, and it will be very easy. Don't worry about it. All right, great. Next. Now, if we have, okay, this we have done. Next, suppose if we have a cubic polynomial. Now, let me just tell you one more time. For cubic polynomial, the questions haven't been asked yet. But for this year, I don't know why I'm getting this feeling that you might get this question. So it is very important you remember this, that sum of root is what minus b by a. The sum of roots taken two at a time. This is nothing but fancy way of saying that alpha beta plus gamma alpha is given by c by a, and the product of roots alpha beta gamma is given by minus d by a. How will I remember this? The sum of roots, I will take this as minus b by a. This will be always plus, that is c by a, and this will always be negative, that is minus d by a. So again, once again, be with me. Alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus gamma alpha. What do I call this? Sum of roots taken two at a time is c by a, and alpha beta gamma is minus d by a. Give me a thumbs up or any sign of your presence that you are here with me. Okay, great. Thank you so much. Let's move forward. Now, this is a very small chapter. I have covered all the important questions. Let's move to some important previous year questions. All right. Before that, again, let me just quickly summarize this. What we are studying polynomials. What is the general form of polynomial we studied? What is the condition for the polynomial that the exponent should be a non-negative integers. The variable should never come in the denominator. And the last is the coefficients should be a real number. We saw the geometric meaning of zeros. We never haven't done the question. I'm just waiting for. We will do some important previous question and we will cover that only. The geometric meaning of zeros are where the graph of the function intersects the x-axis are the zeros, nothing else. Now, if you have a quadratic polynomial of the form y equals to ax squared plus bx plus c, the sum of roots, that is alpha plus beta, will be equals to minus b by a. What is b? Coefficient of x over a. What is it? Leading coefficient or the coefficient of x squared. What is product of roots? Alpha beta equals to c by a. C is what? Constant of a. Again is a leading operation or coefficient of x squared. For cubic polynomials, what do we have? Alpha plus beta plus gamma is minus b by a. That is sum of roots. The sum of roots taken two at a time, that is alpha, beta, gamma, gamma, alpha. The sum is c by a, and alpha, beta, gamma, the sum is minus d by a. Are you following me up till now? Great. So let's dive into some important previous year questions. We are going to solve around 15 or 12 to 15 questions. I will be fast. Don't worry about it. Let's start. So the first question is, if one of the zero, now you will see the question and you will realize how important the formula is. If one of the zeros of polynomial a minus 1 x square plus ax plus 1 is minus 3, what is the value of a? See, first of all, if one of the zeros of polynomial is minus 3, that means if I'm putting x equals to minus 3, I will get the answer as a. The answer is 0. So let's just do this. I will get a minus 1 times x square is what? Minus 3 whole square. That is simply 9 minus 3a plus 1 equals to 0. Yes or no? Next, I will do what? 9a minus 9 minus 3a plus 1 equals to what? 0. 9a minus 3 is what? 6a. 6a minus 9 plus 1 is what? Minus 8. I will take this to the other side. I will get 8. So I will get a equals to 8 by 6. Or if I simplify this, I will get 4 by 3. Got it? Yes or no? Great. Good to know. Good to know. Let's move forward. I believe these are two marker questions, and this came in 2024. If you know this, see what is it? 0. If I put the value of x in the quadratic polynomial, the answer will be 0. So this is pretty clear, right? Let's move forward. Now, for what value of k, the product of the polynomial, product of the zeros of the polynomial is 2. So what do we have? One more time. We have polynomial kx square minus 4x minus 7. The product of the zeros is 2. What is product of zeros? That is alpha beta is given to us as 2. What is alpha beta? C by a. That is minus 7 over k equals to what? 2. I will take 2 here, k here. I will get k as minus 3.5. Again, this question came in 2024, 2 marks in your bag. Congratulations. Let's move forward. I believe up till now the questions are very easy. We are being just be dealing with very easy questions. Next, okay, this is an assertion reasoning type of questions. What is given? The zeros of the polynomial p of x is equals to x square minus 2x minus 3 are minus 1 and 3. The reason is graph of the polynomial p of x intersects the x-axis as minus 1 comma 0 and 3 comma 0. Now, if you are not aware of the directions, I'll just quickly go through this. A option we choose when A and R, that is assertion and reason, both are true, and reason explains assertion completely. We choose option number B, and perhaps the most trickiest option, where A and R both are true, but reason R does not explain this. C option we choose when assertion is true, but reason R is false. And D option we choose, assertion is false, but the reason is true. These options are pretty standard for 10th class, 12th class. Even after your graduation, you will always find this A, B, C, D. This is universally accepted. All right, let's move forward. We have, let's see the assertion. We have zeros of polynomial x square minus 2x minus 3 are minus 1 and 3. Let's put minus 1, what I will get? 1 plus 2 minus 3. That is 0. So minus 1 is 0, 0, correct. 3. How will I check? I will put x as 3. I will get 9 minus 2 times 3 is what? 6 minus 3 again 0. So clearly these two are the zeros of the polynomials. And since if these two are 0, the x-axis it will intersect at minus 1 comma 0 and 3 comma 0. So its graph will somewhat, if this is minus 1 and this is 3, the graph will somewhat look like this. Got it? Great, great, amazing. Let's move forward. Now we have the zeros of the polynomial x square plus px plus q. This question also came in 2024. Very important. We have the zeros of the polynomial x square plus px plus q are twice the zeros of the polynomial 4x square minus 5x minus 6. The value of p is what? So we have what two polynomials? First is x square plus px plus q, and the second polynomial is what? 4x squared minus, this is x squared, minus 5 of x minus 6. Now, what we have, the zeros are twice the, so if the zeros of this polynomial are alpha and beta, that means the zeros of this polynomial are what? 2 alpha and 2 beta. Why? Because it is given in the question. Just read the question one more time. Zeros of volume, this is a twice the zeros. So obviously 2 alpha, 2 alpha. Now, see, one thing is, let's find the product of roots here. What is alpha beta? C by A. That is what? Minus 6 by 4. Yes or no? In this case, if I find, I will get 4 times alpha times beta is what? C by A, that is Q by 1. Now, alpha beta is what? Nothing, minus 6 by 4. I will just put it here. I will get Q value as negative of 6. So value of Q is 1, but do we have to find value of Q or value of P? Of course, we have to find value of P. So what? Nothing to worry. We have, what is the value of alpha plus beta here? Alpha plus beta here is what? Minus b by A, that is 5 by 4. And Q value we have already found. What is the value of Q? Minus of 6. So we'll just put it here and we'll get our answer. I hope it is clear up till now. Yes or no? Great. Let's do one more question. What is the question? If the sum of the zeros of the polynomial p of x is equals to 2x square minus k root 2x plus 1 is root 2, what is the value of k? Again, if the sum of roots is sum of zeros is given, that means we have given alpha plus beta. What is the value of alpha plus beta? Minus b by a. That is minus of minus k root 2. That is plus of k root 2 over 2. The answer is given equal, this sum is given as root 2. So root 2 will get cancelled. What is the value of k we get? We will get k as nothing but 2. Another 2 marks in your pocket. Congratulations. This question also came in 2024. I'm pretty sure everyone is following up till now. If you have any doubts, you can let me know. I'm I'm hoping that these sessions that we are covering are helpful for you. Again, this session, let me just tell you, we have started the session from 2 3 days prior. Up till now, we have covered trigonometry, coordinate geometry, and arithmetic progressions. Today, I'm covering two chapters, that is real numbers and polynomials. Tomorrow, from today onwards, and tomorrow up till 10th, that is your 10th March, when your exam is happening, we'll be continuously having this series. So it is very important that you join the series. Every day, we are going to have two sessions, one in the morning at 11:30 a.m. Let's just skim through the revision topics. Actually, not skim, we are going to get into the details. And one will have a session in the evening where we will do some important previous year questions. It is very vital that you join this session because these questions are very, very, very important for examinations. For the entire 10 days, we will make sure that you will revise all the concepts. All right, great. Let's move forward. Now, which of the following is a quadratic polynomial with zeros 5 by 3 and 0? One option is like you put the options here and you find the answer. Other easier option is what? I will just simply stop being lazy. I will write x minus 5 by 3 and x minus 0 is what? X only. So if I open this, I will get x squared minus 5x by 3. Next, if you see option number C, it is close, but it is not our answer. Why? Because we can also simplify this further. We can write this as 3x squared minus 5x. Now 3 will go to the other side. Yes. So I will what take 3x common. I will get x minus 5. So what will be my answer? Here, the option number B. Clear? Yes. All right, great. Let's do one more question. Now, this is one important question. Why? I'll tell you. What we have to do, we have alpha and beta are the zeros of the polynomial this and this. We have to find the value of 1 by alpha plus 1 by beta. First of all, what I know that here alpha plus beta is what? Minus b by a. What is b? 1. That is minus 1 by 1. That is simply minus 1. And what is the value of alpha beta? Nothing. C by a, that is minus 1. So there we have it. We have the value of alpha plus beta also. We have alpha beta also. So what you have to find value of 1 by alpha plus 1 by beta. I can simply write this as alpha plus beta over alpha beta. Yes. Now what is the value of alpha plus beta? Minus 1. What is the value of alpha beta? Minus 1. Minus 1 by minus 1. I will get the answer as 1. So which is the correct option? Option number A. Clear? Up till now, very clear. Yes or no? Okay, great, great. Let's do one more. So this is a very important question, and these questions have started coming recently. That is based on case study question, and these are my personal favorite. This is a question that came from 2022, and this is very important. Just just understand how to understand this question. This is important. What is this? So a car is moving on a highway. The path it traces is given below. So highway, if you have been showing, highway can be like going like this. If you have been to mountains or somewhere else, it is going like this. Sometimes you have to go up, sometimes you have to go down. Yes or no? Okay, great. So what does it say? A car is moving on a highway. Its path is given below. So this is the path. All right. Now, there will be certain questions that will be coming with us. First of all, what is the shape of the curve EFG? Where is EFG? This is EFG. This is what? Nothing. Parabola only, right? Downward parabola. If you have remembered the question, the session I had taken for the quadratic equations, you must be saying that this is a parabola. And that too downward. So clearly option number A is correct. Straightforward. Next, with the curve ABC. Now this is the curve ABC. Again a parabola is represented by the polynomial minus of x square plus 4x plus 3, then its zeros are what? Now see, there are two ways of attacking this question. First of all, you have this parabola in front of you. You factorize 4x plus 3x plus x, so I will get x square plus x plus 3x plus 3. You take x as common, x plus 1 plus 3 common, x plus 1, then I will get x plus 1 plus x plus 3 equals to 0, x equals to minus 1 and x equals to minus 3. So I have there one method to do that, but again, it is taking time. The second thing is you see the geometrical meaning of the zero. Now look at this path, curve A, B, C. This is a parabola. If we consider only this portion of the curve, at which points it is cutting the x-axis? It is cutting at -3 and it is cutting at -1. Yes or no? So if it is cutting at 2 points, these are the zeros. We have -1 and -3. So which is the correct option? Option number D. Pretty clear, very easy, right? Next, let's look at the another part of this question. See, these are case study questions, very easy to follow, and you will get straight 5 to 6 marks in your pocket very easily. Now, what is the question saying? If the path traced by the car has zeros at -1 and 2, then it is given by what? So again, see, this is a parabola. We are talking about CDE. You have to find its equation. Let's find it. Very easy to find. Again, how will I do? I will write this as if it has two zeros, that is x of -1, that is x plus 1 times x minus 2 equals to 0, or just leave it like this. If I simplify this further, I will get x square minus 2x plus x minus 2. So this becomes x square minus 2x plus x is what? Minus x minus 2. So which is the correct option? Option number C. Are you getting up till now what I'm trying to say? Great. Let's move on. Let's do one more question. The number of the zeros of the polynomial representing the whole curve. Now we have to see the whole curve. Now how will I see that? Now this is a very, very important question. See, if we are considering about the whole curve, that means that we are seeing A, B, C, D, E, F, G, and H. Now, what are the geometrical meaning of zeros? It is the point at which it cuts the x-axis. I am seeing this is first point, this is second point, this is third point, this is fourth point. In total, I'm able to see 4 points. Can you see more? No. So that means how many number of zeros it will have? It will have clearly 4 zeros, which is the correct option. Option number A. Got it? Great. Next, one more question, perhaps the last question of the series. We have the distance between point C and G is what? Now, see, this is the concept of coordinate geometry, but that's why these type of questions are very important because it is the amalgamation of multiple concepts. So if you have to find distance between point C and point G, I have C as -1 and G as 5. So what is 5 of -1? I will get as 5 plus 1, which is nothing but 6 units, which is the correct option, option number B. Clear? Yes or no? Great, great, great. Let's do one more question. I hope up till now you have been clear. Okay, so we have one more part to this question. It is given the quadratic polynomial, the sum of whose zeros are -5 and the product is 6 is what. This has nothing to do with this. It's just given it like this only. So remember, I told you whenever you have to find, I will write it as x square minus this. What is the sum of roots? X square minus alpha plus beta x, that is x square minus sum of roots times x plus the product of roots. So what is the sum of roots? It is given as -5. So minus of -5 will give us plus 5x plus the product of roots, that is 6. So which is the correct option? It is option number A. You got it? Great, great, great. Many of you got it? Nice. Okay, so that is the end to that series. Let's look at some more important previous year question before we like fully say that we are done with this chapter. Now, again, this is similar to the question that we have done up previously, and if you can see this is like the pattern of CBSE. It came in 2022. It has came in 2015. Who knows? This comes in 2025 or not? Okay, we have to find the polynomial whose roots are 3 and -4. So what I will do, I will simply write this as x minus of 3. You can see how easy these questions are. Times x minus of -4. This is where you can make mistakes and don't want to do. So do it very slowly. If I open this, I will get x squared plus 4x minus 3x minus 3 times 4 is what? -12. So here we have x squared, 4x minus 3x, I will get x minus 12. And this is my answer. Yes. No need to write 0 because we have to find only polynomial. We don't have to find equation. Getting it up till now? Are you following whatever I'm trying to say? Are my words reaching your ear, your mind, your body, your soul? Okay, great. Let's move forward. What do we have? If one of the zeros of the polynomial is reciprocal of the number, okay. See, what is given? We have a quadratic polynomial given, and it is given the one zero is reciprocal. What is the meaning of reciprocal? That means if we have one zero is one alpha, the other zero will be one by alpha. Yes or no? Yeah, that's what reciprocal means, right? So that means if I'm multiplying the two zeros, what will be the answer? Very tough question. Alpha times 1 by alpha, it is given as 1. So what does this mean? That is the product of the polynomial, product of the roots of the given polynomial will be 0. So will be 1. I'm so sorry. That means C by A will be 1. That is negative of K minus 2 over 6 will be equals to what? 1. Now very easy to solve. I will get K minus 2 equals to negative of 6. I will take negative to the other side. I will get k equals to negative 6 plus 2, that is negative 4. Pretty easy, right? Great. Let's do one more. Are you following up till now? If you have any doubts, I'll just take 1 minute pause. If you have any doubts, you can let me know in the chat box. I will try to answer all of you. No doubts? Great. This is a sign of a good student. No doubts. Okay. Now what we have? If alpha and beta are the zeros of the polynomial x square minus px plus 1. This came in 2016, by the way. X square minus p of x plus 1 plus c such that alpha plus 1 is alpha actually times beta plus 1 is 0. We have to find the value of c. Now nothing. If I have no idea, I will just simplify this. I will get alpha beta plus alpha plus beta plus 1 equals to 0. Now alpha beta is what product of roots, that is c by a, which is nothing but c. Next, what we have, alpha plus beta is given as minus of p, that is plus p by 1 plus 1 equals to 0. Yes, because why? Don't get confused. It is nothing but x square minus p of x plus p plus c, right? So here constant term is p plus c. So this will become p plus c. This is b is minus p. So it will become p plus 1 equals to 0. So I have 2p plus c plus 1 equals to 0. That means if I take everything to the other side, it will become c will become negative 2p negative 1. You got it? Yes. Great, great. I'm pretty sure everyone has understood up till now. Let's move forward. What we have to find a quadratic polynomial whose zeros are reciprocal of the zeros of the polynomial ax square plus bx plus c. Now, dear students, one very simple trick to remember is obviously this came for 3 marks, but always remember whenever we get this type of questions, just write it backwards. That is cx square plus bx plus a. But for this time, we are going to completely derive it for you. I'm so sorry. This we done, this also we have 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 done. Okay, this we are doing. Okay, so for this, what I will do, first of all, I have to find who's reciprocal. That means if the roots should be 1 by alpha and 1 by beta, right? Now, let's find the sum of roots. 1 by alpha plus 1 by beta will be given by what? Alpha plus beta over alpha beta, right? What is alpha plus beta? Minus of b by a. And what is alpha beta? C by a. So I have found the sum of roots as a and a will get cancelled as minus of b by c, right? Similarly, if I have to find the product of roots, what I will do? That is will be nothing 1 by alpha times 1 by beta. Or I can simply say this will be 1 by alpha beta. What is alpha beta? C by a. So this will become a by c. Now nothing to do. We will just write it as x square. I told you minus sum of roots, that is b by c times x, plus product of roots, that is a by c. So there we have it, folks. We have cx square minus bxc plus a. This will be our answer. What I told you earlier. Is it clear? Okay, great. Wonderful to know. Let's move forward. Now, one another question is we have to find the value of k such that the sum of its zeros is equal to half of their product. What is trying to say, my dear students? It is saying that alpha plus beta should be equals to half of alpha beta. Now, what is alpha plus beta? Minus of b by a, that is nothing but k plus 6 is equals to half of alpha beta, that is 2 times 2k minus 1. 2 and minus 2 will get cancelled. I will solve this. I will take 1 to the other. I will get 7 equals to the value of k. Is it clear? Yes or no? Final revision. We are doing some important chapters. We will continue to do some chapters. Don't worry about that. Is it clear up till now? All right, great. Next, another. This is not previous year question, but this is a question, a very important question, which has come from sample papers, which we are going to do. Hello, everyone, dear students. Those who have joined late for cubic, I don't know. Okay. All right, great. So, what is this? Let's just read this question. The question is Annie was standing on a diving board. You have seen some swimming videos. If you haven't, don't see now because the exam is coming. So, what is this? Annie was standing on a diving board 48 feet above the water level. If you can see, this is 48 feet above the water level. She took a dive into the pool. Her height in feet above the water level at any time t is given by polynomial h of t such that h of t is equals to minus 16 t square plus 80 plus k. No, don't get confused. Imagine it like this. There is Annie sitting on top. Now she's going to take a dive. Her dive will be somewhat like this. Yes or no? This is nothing but a parabola, right? And this parabola is given by h of t is minus 16 t square plus 8t plus k. And her initial height was 48 feet. So what is we have to find? First of all, what is the value of k? How will I find this? In order to do this, what is the initial level? That is, if at when t was 0, the height was 48, right? That is what initial level means, right? So I will just do 48 equals to minus 6 times 0 plus 8 times 0 equals to k. So there we have it, the value of k as 48, pretty straightforward. Yes or no? You understood? Great. Let's move to the next part now. The next part thing is, at what time will she touch the water in the pool? Now, see, if she is going like this, she is going to take a dive like this. That means her height should be 0 at that time, right? That means water level, if she is reaching the water level, the height at that point will be 0. Then what we will do? We will just do minus 16 t square plus 8t. We have found the value of k. That is nothing but 48 equals to 0. If I simplify this further, I can always take 8 as common. I will get minus of 2t square plus, this is nothing but t, plus 48, I will get 6. Now, if you find this equation, you will get the answer as 2 6. Is it clear up till now? Great, great, great. Let's move forward. Let's do one more question. Now, there's another girl came, that is Rita. Her height in feet above the water level is given by another polynomial where zeros are minus 1 and 2. Then P of t is, oh, this is a very easy question. How will I do this? I will just write this as t minus of minus 1, that is t plus 1, times t of minus 2 equals to 0. If I simplify this further, I will get t square minus 2t plus t, that is t square minus t plus 2. Sorry, plus t minus 2, which is my option number A. Is it clear? Great, great. Let's do one more part of this before we end the session. Now, what is the session of polynomial QT with sum of zeros as 1 and product -6 is modeling a nose height? A nose is another girl. Then QT is what? This is a very easy question. Why I'm even solving this? Again, it is T. Sum of zeros is what? Nothing, -1. So I will write minus T. And product is -6. So -6 equals to 0. This is minus. Is it clear? Yes. Great, 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 great. Good. Let's do one last question for this session. I hope we have, this is what, 50th question. We have solved 50 questions in the past 90 minutes, and I hope this discussion was fruitful. Just one last question. Why I wanted to bring this question is of the thing that is additive inverse. What do you mean by additive inverse, my dear students? Additive inverse are like if we have alpha, then another root should be equals to minus of alpha. That means the sum of roots will become what? 0. And here, what is the sum of roots? Minus of b by a, that is minus of k minus 3 minus of 12 equals to 0. So there we have it. The value of k is nothing but 3. So option number A. Hello, dear students. I hope this discussion was fruitful. What we have done up till now, let me just quickly try to summarize this. All we started with real numbers. Real numbers we have studied. What are rational numbers? What are irrational numbers? We have studied fundamental theorem of arithmetic. What does it say? Let me just quickly tell you one more time. If we take any composite number, it can be expressed in the product it can be expressed as product of primes, and this prime factorization is unique apart from the order which it occurs. Next, we studied the relation between LCM and HCF. First of all, LCM is HCF. How will I find? I will take the common prime factors and their highest powers. Done. Lowest powers, sorry. Done. LCM, how will I find? I will take all the factors, be it common or not common, nothing doesn't matter. I take all the factors and their highest powers. What is the relation between HCF and LCM for two numbers? HCF times LCM is equals to the product of two numbers. We don't have to worry about three numbers, but it's still, I am once again saying it is good to know if it's up to you. But good to know, yes. Then we did some amazing problems. I have told you how to prove irrational numbers. To prove irrational numbers, we must know the theorem that if p divides a square, for sure p will divide a. We have proved the numbers irrational using method of contradiction. You remember that thing. All right, we did a few problems. If you haven't like joined from the start, make sure you join it now. Those are some very important problems. Next, we move to polynomials. We saw a mathematician, actually a French mathematician philosopher, laying down and seeing a fly flying on the fan and how it came to discovery. Now, what is a general form of polynomial? We have no need to remember that. The important thing is that exponent should be a should be a non-negative integer, that is 0, 1, 2, 3, 4. It should the variable should never be in the denominator, and the coefficient should be rational number, real number. Sorry. Next, we done for quadratic polynomial. Perhaps the most important is sum of roots is what? Minus b by a. The product of roots is what? C by a. For cubic polynomial, sum of roots minus b by a. The sum of roots taken twice or two at a time is c by a, and product of root is d by minus d by a. We haven't done any question because it haven't been asked, but I will make sure to post one question and comment. If you type, sir, please post a question. Of course, I will reply to you. If you have any doubts up till now, whatever we have studied, these two chapters, make sure to write in the chat box. And one more time, my dear students, it is my privilege to tell you that we have started this session and we are going to continue this till 10th of March, till your examination comes. So thank you so much for joining. Make sure you like, comment, and subscribe. If you like what we are doing, you can support us by always subscribing to us, liking, and spreading the word. It's good to know. So thank you so much, dear students, and I'll see you in the next video. Bye bye.